Okay, we're gonna talk about the EVM, which I feel like does not get the energy that it deserves anymore. Today I'm with Keone and Lei. Do you guys want to give a short introduction of who you guys are, and then we can get started?
Sure. Hi, great to be here. Keone Han, co-founder of Monad. Monad is a new upcoming EVM layer one that's introducing a bunch of new technology, both on the consensus side and on the execution side and on the database side to make the EVM really performant and cheap.
Hey, my name is Lei, and I'm a co-founder and CTO of MegaETH. MegaETH is an what we call a real-time blockchain. By real-time, we mean that it responds to user transactions almost instantaneously, and it can handle a really large workload, so that whenever you submit a transaction, you get your feedback almost instantaneously, and you kind of get this Web2 feeling when you use that app. And it's an EVM-compatible chain living on top of Ethereum. Depending on Ethereum security. Yep.
Perfect. To start us off, what were the existing problems with the EVM that you guys are now trying to solve separately?
Yeah, just to mention a couple really briefly. Right now, EVM execution is all serial, so it's just one after another. That is not only a problem from a CPU perspective or computational perspective, but it's also a problem from the perspective of identifying state dependencies and pulling lots of state from SSD in parallel. So Monad is introducing parallel execution, and not only is that helpful for parallelizing compute, but really it's important for surfacing many dependencies from state in parallel, pulling a lot of dependencies from SSD, and ultimately still producing the same end result as if those transactions have been run serially.
I'll answer the question in a kind of a collaborative way. I think Keone mentioned that there's no built-in helpers for facilitating parallel execution. So I'll talk about a few other pain points. I think one of them is the state trie. So we know that Ethereum, the EVM, has this very nice succinct commitment to current world state. The entire multiple gigabytes of state is committed within this so-called Merkle-Patricia trie root, right? But however, computing this Merkle-Patricia trie, especially updating it after executing every single block, is very expensive. So what we have been doing is that we built a new data structure. It's not just a re-implementation of the Merkle-Patricia trie, but it's a brand new data structure along with an implementation that is just much faster to update than the traditional Merkle-Patricia trie. And I think the second is the EVM is so-called a virtual machine. That's what VM stands for, right? And by being virtual, it means that it's different from the physical infrastructure, the physical CPUs and your silicon that actually executes the transactions. So by translating your transactions written in Solidity to the native instructions that your computer hardware can understand, there is significant efficiency loss. And we're talking about tens to 100 times efficiency loss. And what we have been working on is so-called a JIT compiler, a just-in-time compiler that translates your smart contracts into what your computer can understand and can execute most efficiently just before your transaction is being called, so that we hide this inefficiency between EVM and your native infrastructure, and when your transaction is being executed, is enjoying the full speed of your native hardware.
Keone, do you want to run over some of the? I feel like you didn't get the chance to talk about some of the improvements that you guys are making to the EVM as well.
Sure. Yeah, just to mention a couple of different areas. So Lei was talking about, I guess, rebuilding a data structure to make it faster to access the Merkle tree. So Monad has built MonadDB, which is a new database basically for storing the Ethereum Merkle tree natively on SSD much more efficiently than the existing approaches. So for background, there's a number of different Ethereum clients. There's Go Ethereum, there's Reth, there's Aragon, and there's Lighthouse, and sorry, that's a consensus client. But Anyway, the point is there's a bunch of different Ethereum clients, but they're all actually using commodity databases under the hood. So they kind of delegate the work of actually storing all of the data on the SSD to another piece of software, typically LevelDB, or in some other cases, PebbleDB or RocksDB. And those databases basically they're generic, so they're smart, but they're smart for a general case. But the Ethereum Merkle tree is actually a very specific data structure. Like, we know a lot about the way that the Merkle tree is laid out. We know that when we modify one of the nodes in the Merkle tree, we're going to have to ultimately end up modifying all of the parents all the way up to the root. And so by more intelligently choosing the page layout, as well as just literally like storing the Merkle tree on the disk, and also bypassing the file system with IOU ring and various other improvements, we can achieve much faster access to that state. And the thing that I always like to explain about SSDs is that you can think of it as a bottle that has a very wide bottleneck, and the job of optimizing the flow of liquid out of the bottle really entails sticking a lot of straws into that bottleneck all at the same time. And basically, by both intelligently storing state in pages, like locating information that is needed next to each other, also bypassing the file system, and then accessing a bunch of state in parallel due to optimistic parallel execution, we can effectively pull a lot of liquid out of that bottle all efficiently.
Yeah, and I think I'll just kind of expand a bit on this topic. Kind of out of the Monad Mega ETH context. So I think there have been other very interesting initiatives in the community, in the EVM community. I think there's one called Near Optimal Merkle Try. I think this effort is more like what Monad's taking. I think it's preserving the Merkle Patricia Try data structure, the theoretical construction of it, but just doing a much better, like a much more specialized implementation of it. And there's also, sorry, I think okay, so the name is QMDB, and it's more like our approach. So we are literally changing the construction, like the logical construction of Merkle Patricia Tries. We're preserving the functionality, but the inner works, even in terms of the math, is different. And we kind of build a new data structure along with a new implementation. So that's QMDB and also our Merkle Try like replacement. So just to want to give everyone the context. So I think definitely the entire community is recognizing that updating the state root is probably one of the most important bottlenecks in speeding up EVM. So there's actually pretty exciting initiatives all across the board. Yeah.
Right. So out of curiosity, with that QMDB, does that mean the root is not a Merkle root? It's like a different kind of root?
Exactly. So QMDB and our data structure, the roots should not be called a Merkle root anymore, because it's changing the definition of, it's not like a re-implementation of Merkle Patricia Try. It's a new data structure. Like the mathematical definitions has been changed, but the functionality it provides, which is to give you state commitments and give you proof of individual state slots, is unchanged. So it's like it preserves the interface, but changes the inner works.
I see. Yeah. So I feel like that's an interesting
trade-off.
Yeah. Is that by with the Monad approach, we chose to preserve the Merkle tree and the Merkle root because we feel that it's really important to preserve Ethereum compatibility. And there's a lot of infrastructure that connects to blockchains, such as bridges or other things like light clients that basically have an expectation of, I don't know why I'm thinking of proteins that attach to receptors on cells. But we want that exact shape of receptor. Whereas it sounds like you guys have changed the.
Yeah. So what we do is that we preserve the functionality of it, so that if your program adheres to the EVM definition, especially the functionality that a state try should provide you with, then your program does not need to change anything. You don't really to modify your program. But yeah, I agree. It's a kind of a different approach. That's it's two points on the trade-off. I think for Monad is to really be identical in terms of how EVM behaves. And for us, it's all about preserving the functionality and the interfaces, the guarantees that EVM gives you, but replaces the inner mathematical definition of the state tribe. It's really because we kind of see a fundamental limit, even just mathematically, you can write a proof for it that there's some fundamental limitation of how fast you can scale a Merkle Patricia try to. I think Monad, I think also along with NOMT near optimal Merkle try, I think you guys kind of pushed the Merkle try to really to the extreme, right? To the extreme of physics. I think what we are doing is we're kind of thinking a little bit more ahead, and I mean not really ahead, but we're kind of a bit worried about like this mathematical limit of how fast you can scale Merkle try. So we thought that might as well just replace the definition of it altogether.
Perfect. What are some things that the EVM does better than the SVM, such that you guys chose not to use the EVM, the SVM?
Yeah, I can take that question first. I think it's mostly about reducing friction for developers, and also just the talent pool in terms of EVM builders is just much larger than SVM. I met this person in the apartment building I live in. So he saw the MegaETH T-shirt, and he approached and said, "Are you with MegaETH?" Yes, I said I work with MegaETH, and then we sat down for 2 hours of just pure discussion on EVM and market making on EVM. So he's a market maker. He's a very small team, and I asked, "Hey, what chains do you operate on?" And he said, "We only operate on EVM compatible chains." And then I asked, "Hey, is SVM just so hard to work with?" He said, "No, probably not. Nice APIs to work with, but for a small team, just doesn't make sense economically for them to spin out and like an SVM sub team. It's just 3 people, right? And it's just so hard for them to allocate one more person to work solely on SVM. And if you build an infrastructure for SVM, you probably only benefit from like market making or Solana. But if you support EVM, you have such a great number of chains to work with. So I think this kind of minor details, especially for small teams, I think they matter. So yeah.
I agree with all of that. I guess I would also just add on the infrastructure side, there's a variety of great Oracle providers, a variety of great bridge providers, a variety of block explorers that people are familiar with. Smart contract verification is like very much a common standard within the EVM, and we see very few verified builds in the SVM space right now. That maybe it's more of a cultural thing, but yeah, there's just, I think the tooling is much more mature, and then that ends up showing in terms of the productivity for developers.
Where and what chains do you guys see users coming to MegaETH and Monad from? Who's the ideal?
It's a bit hard to tell because I think both networks are pre mainnet. I think to me, I can try to speak of what's like more exciting to me, right? What's my ideal scenario? I think for me, it's about attracting users from non-crypto ecosystem, right? We hope that we can attract net new users into just the entire crypto industry, because the way that we can make dApps more usable and more powerful, right? And I think PvP among chains, I think it's fun, but I think it's probably long term it's not really helping the industry. And I think with the regulatory environment shifting, I think there's actually a pretty good chance that we can onboard a bunch of like normie users in this cycle. So yeah, that would be my ideal scenario, just to extract users from Web2 instead of from another chain.
Yeah, totally agreed. I think that there are a lot of things that are table stakes with respect to chain launches, and that means having great infrastructure providers, block explorer, liquidity, bridges, a lot of like steps that happen going up leading into mainnet. But that really should just be like the table stakes. And what I really challenge our team to focus on is how do we do something new? How do we do something different? How do we get new people using Monad Testnet and using crypto in general? How do we get people installing a crypto wallet for the first time? How do we get those 200 million Coinbase users that have never installed a wallet before, never actually used the blockchain to try it out for the first time? So agreed completely with you, Lei, that the Twitterverse has narratives and has things that we talk about on a daily basis, but it's very insular. And I think we all know, I'm not saying anything new. It's not it's not revolutionary or rocket science, but I would just say that there's a much bigger world out there. And for any chain that is launching, the leaders should really emphasize to their team that just getting users from other blockchains and getting them to migrate liquidity over, all of that should not be the KPI. That's not success. That's just sort of again, a baseline level of thing to be done.
What's the most interesting thing in crypto today to you, and how are you guys planning on bringing them to your chain?
I think futarchy is pretty interesting. So futarchy is the idea that we basically have an asset that's already trading, and we kind of fork it into two hypothetical versions of the token that, one which corresponds to deciding yes on a decision and one which corresponds to deciding no on that same decision. And then we just let them both trade. And then after a little bit of time, we see which version of that token is more valuable and adopt the decision, based on whichever one resulted in the most valuable token. So it's kind of a market-driven, really well thought out mechanism. And by the way, it's not just for two-way decisions. You could fork n different ways. But a super interesting way of using decentralized markets to make decisions and let the market decide.
Yeah, I think for me, one of the most interesting applications, I'll just speak of the Mega Mafia, our semi-incubator accelerator program. I think to me, one of the most interesting applications is a decentralized VPN. It's actually about using crypto as literally as it's what it's designed for, which is a uncensorable, always unbiased computing platform. Because with VPN, this is actually pretty sensitive in some countries, right? You cannot publicly market it, and sometimes you are not even able to download the VPN client yourself, right? So I see crypto as a pretty interesting way to circumvent censorship and just to give people access to, I think, this kind of basic needs, which is privacy, which is access to free information, something like that, right? And the way it works is that it settles payments and also settles the routing configuration, route planning for the VPN, fully on-chain, so that there's no off-chain server that you have to worry about whether you can connect to. And it's purely peer-to-peer, that you're literally connecting probably to a box set up in one of the service provider's apartments, right? I just see this kind of grand level service coordination to be quite interesting, and I think it's a pretty good fit for high performance chains.
Crypto over the past year and a half, I would say, has been dominated by trading and trading infrastructure, token launchers, clubs, trading bots. Is this something that you guys are focusing on, given that you're both very fast chains?
Yes, absolutely. We think that high fidelity DeFi makes a lot of sense in the context of a really performant EVM compatible layer one. I guess what I would emphasize is that although there are different points on the trade-off spectrum from decentralization and performance, Monad is on the extreme end of it's on an isocline that is higher up in terms of performance and decentralization. So you can get a really performant order book DEX that is on a very decentralized environment with, basically interacting with the DEX is happening at half a second's time, which is like the time that you are actually like seeing things happen and reacting to them anyway.
Yeah, we are definitely very interested in trading, and there are multiple clubs, each working on different types of assets that are being built on MegaETH. Yeah, so I see trading as quite useful application, but I don't really think trading itself is what. I mean, I should clarify. So trading crypto coins on crypto platforms, I don't think it's like the fundamental use case, right? Because it's kind of it's kind of it's a checking out problem, right? You are trading something that only exists because of crypto, and if you use trading crypto as the pure motivation of crypto, then I think it's kind of that's definition of Ponzi schemes, right? So I think I do hope that there's more like non-trading applications that can actually generate value and extract value from places that is outside the crypto ecosystem. And with this net volume going into crypto, then I think crypto trading actually becomes something that is not speculative and it's not gambling in nature. And I think Keone also touched on like philosophy and kind of trade-offs in terms of decentralization and the performance. I think, yeah, we take a slightly different trade-off. I think both our teams are on the Pareto frontier in this decentralization versus performance trade-off. But I think for us, the philosophy is just we max out performance, and basically every part of the design is to facilitate performance. And once we guarantee that, we seek how to improve decentralization within the assumption that it doesn't really hinder performance. Yeah. Just I think different trade-offs and yeah.
Perfect. What do you guys see as the value driver for chains?
I would say at the end of the day, the value driver is the value to end users. So at the end of the day, it's like if you have, like, I think about Twitch as a great example where, to your point, Lei, about like, right now exchanges feel like they might be a little bit PvP where one person wins, the other person loses. But in traditional equities markets, it can be a situation where everyone wins because while the exchange makes money every day and market makers make money almost every day, people, average, retail or institutions trading also make money because they're trading assets that generate revenue and have like cash flows, and they can invest in Facebook at 2012 and have it go from, go like 20x from then to now. So it's clear that getting assets, like solving the value problem, is fundamentally about enabling useful activity where users get real utility from the rest of the world. So to go back up the stack to my point about Twitch, I like it as an example because it's a situation where technically, like, people that go on Twitch and buy gifts or pay tips to the streamers, their P&L on every single tip they make is negative 100%. Like, they lose all their money every time they make a tip. But what they're getting in return is happiness from the happiness of supporting their favorite streamer and the entertainment of enjoying that. And the streamers make money and Twitch itself also makes money. So it's win-win-win. And I think at the end of the day, the value driver for any like underlying infrastructure is fundamentally capped by the amount of value that can be created on the applications that are built on top, where there's like a reasonable cut of the revenue that comes from the network effects of having tens or hundreds of millions of users with balances on chain ready to use those apps.
Yeah, 100%. I fully agree with Keone. So I think the best value that a chain can attract is from outside of the crypto ecosystem, right? I think the very easy question to think about, I think, is basically if a user is paying some non-crypto company for something, right? If a non-crypto company is generating revenue and also profit, how can a crypto project, how can a dApp be built in a way that it's just naturally more attractive than a centralized application, such that a user will stop paying this Web2 company, but instead opt to use the crypto alternative by nature, by instinct, not because of there's some some farmy incentive campaign which is not really, which every one of us know it's not really lasting, right? And I think basically providing true value through the unique properties of crypto, decentralization, censorship, freedom to users, such that it really generates value for users. Then I think this is the true value that a chain generates. And I think Twitch is one good example. I think VPN I mentioned, it's just plain better to use a decentralized VPN if there is one, right? To me, as a user, I would be willing to pay more if my VPN does not get censored every 2 months, right? I think thinking about these kind of examples is, I think, what I would challenge application founders to do.
Perfect. Last question. If you could wave a magic wand and take a feature from each other's chains, what would you pick?
As I mentioned, I think we are both EVM chains. We are both about performance, but I think our approach, the trade-off that we optimize for, right? I mentioned, I think many chains are on the Pareto frontier, so it all depends on the particular trade-off on the Pareto frontier that you choose to operate on. And I think for us, the philosophy is just to max performance, because it max the chance that a new application can be built on crypto, assuming that performance is one of the important limiting factors currently. So I think it's pretty hard for me to just say what feature that we want to take from Monad, because I think we operate on different trade-off points, and the underlying philosophy when we make decisions and when we decide whether to include a feature or not is just very different. Yeah. But I think one thing, I think probably RaptorCast. So I wrote this paper in 2022. It's basically a 2-layer coded broadcast scheme. I think it's very similar to what RaptorCast ended up being. So we decided to deprioritize that project, because we're a smart team and we want to prioritize like chain EVM related stuff, but if we can take engineering work which is done for RaptorCast for us, I think that'd be really nice. It's a really nice scheme. Yeah, and I'm being a network researcher and writing the paper that proposed the same idea in 2022. I'm just very excited about the idea, just on a pure intellectual level.
I'm curious about the ZK proof mechanism. Like, I think that you talked about like a network of provers that generate proofs for the execution of the mega ETH blocks. That sounds like a really interesting element that would add another level of verifiability. So I would be like, interested to learn more about that, and if I could magically take that, that's what it would take.
Perfect. Guys, before we wrap it up, is there anything else that you want to say?
Monad.
Very good. Thank you both for coming on. Thank you to all of you who are listening.
Yeah, thanks for having us.
Thank you a lot.